Welcome to Vision Plus and welcome back to this senior for mathematics and complex numbers. Today we are going to look at the rectangular form or the Cartesian form of the complex number. So example 1 says that we need to convert the given complex numbers into the rectangular form. The solution is the rectangular form of the complex number of any complex number, say z is given as x plus iy. This is what we call the Cartesian form or the rectangular form. They are the same. So we are given the polar form and we need to convert from the polar form into the Cartesian form that we know. Now, we know that at some point when I was deriving the formula for getting the polar form, which is in this format. For polar form is that z is given by r into cosine of the argument theta plus I sine of the argument theta. How we came here was that we had factored out r. So initially this formula was in the form that cosine of theta plus r sine, we say I r sine of theta. We have opened the bracket by multiplying these two terms by r. Now if we are to compare the Cartesian form, which is the rectangular form, and the polar form. Now this term here corresponds to x, and at some point we say that x is given by r cosine of theta. Yes, and that y, on comparing, y is the coefficient of I. So we have I here and I here. So y is the term attached to I. So y is given by r sine of theta. Now, for us to write in the Cartesian form, it means that we need to come back and we substitute x as r cosine of theta, then y as r sine of theta. So for us to get x, it means that it is a product of r and cosine theta, and for us to get y, it is a product of r and sine of theta. So going to example A, part A says that the complex number z is given as, this is in the polar form, cosine of 60 degrees plus I sine of 60 degrees. Close the bracket. What is r here? R here is 5. What is the angle theta? Theta here is 60 degrees. So for us to get x and y, we just come and substitute for r here and then the angle there. Therefore, this implies that x, that we know that x is r cosine of theta. This means that we shall have 5 cosine of 60 degrees. And then you press the calculator. Cosine of 60, it is 0.5. That means we shall have 5 and 0.5. This is the same as 2.5. So x is 2.5. What about y? We come and use this formula that also y is given by r sine of angle theta. This means that we shall have 5 sine of angle 60 degrees. And then we press the calculator, which is, you can press at once, 5 sine of 60 degrees. I'm getting 4.331. 4.330. 0, 1. Remember, you can also express your answer in such form, because sine of 60 is the same as 0, 30, 45, 60. Is the same as root 3 out of 2. Sine of 60 is the same as root 3 out of 2. But this answer is correct. That means 5 sine of 60 here becomes 5 root 3 out of 2. If you press the calculator, 5 root 3 divided by 2, yes, it is the same answer. But to make your work easier, always use the decimal point. It is correct. So now that we have the value of y, then you come and say, therefore, in the rectangular form, we shall have the complex number z being equal to, because this is the general form in the rectangular form. That means what is x? X is 2.5 plus I, y. What is y? Y is 4.3301. And this is the answer for part A. This one is alternative 1, which is correct. Method 2. Let me do method 2 so that we see that it gives the same answers. After that, in the coming examples, I will be using one of them. I will choose one. Method 2 is, you can start by illustrating this complex number on the diagram. So you come and do your diagram in this manner. This is the imaginary axis of z. This is the real axis of z. Real axis of z. This is the origin. If you look at it, the angle is what? 60 degrees. So 60 degrees lies in the first quadrant. So this is the complex number. It's not accurate. 60 degrees. Put an arrow here. That means it will have a corresponding value on x and on y. So this distance of x here is what we are calling x. Then the distance on y-axis, which is the vertical axis, that is the imaginary axis, is what we are calling y. And then r. R is the magnitude of the complex number, which is the length of the complex number, which we have there as 5. So that length is 5. Now what do we need to do? What we just have to do is to find this distance gives us x, and then this distance here gives us y. This side is also the same as y. That means here we need to apply either sine, cosine, or tan. Now that is SOHCAHTOA. SOHCAHTOA. I just want to do this so that we see that this method and this give the same answers. So for sine, we shall use opposite and hypotenuse. Opposite is here, hypotenuse is there. That means sine of 60 degrees equals to opposite y out of hypotenuse, which is 5. Then you cross multiply. This means that 5 sine of 60 degrees equals to y, which is here. Y equals to 5 sine of 60 degrees. Then you place the calculator. It will give us the same answer. 5 sine of 60. Yes, 4.3301 equals to y. And then you go to x. You can use sine, cosine, or even tan to get the same answers. But tan here cannot apply because we don't have y and x. But since you have got y, now tan can now apply because it is opposite and adjacent. You can use this value to get x. Let me apply cosine. So that we say cosine of 60 degrees becomes cosine is adjacent, which is x, out of hypotenuse, which is 5. Then we cross multiply. This gives us a 5 cosine of 60 degrees becomes x, which is here. X is 5 cosine of 60 degrees. And then after this, You press the calculator. 5 cos of 60, 2.5. So 2.5 equals to x. So we have seen that if you're using the graph, you get the same answer as when you are applying this concept of that x equals to r cosine theta and y is r sine of theta. Then from here you can go back and substitute. That means our z becomes the same answer 2.5 plus 4.3301 I. This is the answer. So this is the solution to part A. Let us go to part B.